Okay, so the first step before we start taking this model um, from a model into the production information and drawings is a numbering. So if we go to our drawings and reports tab and we run down to number modified objects, we've now run a numbering on the model. Tekla has compared everything and assigned numbers based on their similarity to each other, which means that similar items or the same items will get the same mark. And so we're going to have a look at creating some GAs now that we've done that. First thing I need to do is create a couple of views, namely plan views. So we'll go to our views tab and create a couple of basic views. The first one I want to create is a foundation plan, so a plan at 0. So let's create that. And a roof plan at 8 meters. So let's create that one. Apply that, create that one. Make sure that we've got those named correctly. Yeah, so we've got this one. That one's in brackets, which means that one exists, which is good. So we've got those two views. If I go back to my drawings tab, create drawings, GA drawing, you can see those views are listed here. So we can use those to create views on the drawings. The next thing we've got to do is specify the drawing layout. So we hit the drawing properties tab, we drop down this menu, we pick foundation plan, we load that and then we store it. And then we select the view on which we want to base that drawing. So in this, for the foundation plan, it's a 0 level. Select the open drawing checkbox and hit create. That's going to create my GA using that plan view that I created in the model, and it's going to open that drawing when it's finished. So there we have it. There's our foundation plan. You can see we've got the layout and we've got a general notes there for the holding down bolt setting, and then we've got the view that I created in the model. So we can start to manipulate this view now. So you can see that grey box is sort of indicating a view, and that pink box is the boundary. Now I can manipulate that in either the model or the drawing, but I'm just going to do it in the drawing for now. So we can grab that handle there on the corner and narrow that field of view like so, just to neaten it up a touch. And I'm also going to need to change the scale. So if I double click on that view boundary, I bring up the properties for the view, and I'm going to change that to 75 just to get it to fit on the page. And then I can drag and drop that sort of in the middle-ish. It's looking a bit too high in the vertical plane there. I want to exclude that cold rolled rail. So if I bring up the view dialog box again, and in this depth up value field, if I set that to 0, I can start to narrow the depth of that view. And if I give it a negative projection, it will look 50 mil further away from me so that I can really only see the base plates, which is what I want. Now, this is the first bit of the recall back to the model. Do you remember that I was looking at the base plate components and I put a label on there of BP1? Let's look at that again, just to remind you. So if we double click on that component, go to general, we put this specification in here in the general tab under connection code. Now that was for the purposes of the general arrangement drawing. So if I open up the foundation plan, I can go into the view properties, I can go to connection mark, which is here, and I can say pull in the connection code from those connections, which is going to give me this little label here, BP1. That performs two functions. Not only does it give me a base plate reference that I can use on the drawing for when I do the base plate details, it also populates this box automatically. So you can see we've got base type BP1, there are 10 of them. These are the holding down bolt specifications. This is the washer plate specification, and this is the setting information. Now that's being pulled in directly from the components. And that will pick up any variations as well. So for example, if I had a fire boundary on grid line 3 and these had 8 holding down bolts in them and they would be BP reference 2, they would be quantified here as well. Okay, so a nice little tip there for making short work of your drawings. You can put dimensions on these drawings as well using the dimensioning tools. So I can put spacing up there for the grids, and I can do the same horizontally like so. You can do that for anything really, anything you want to dimension. I can also add detail views. So I can create a detail view of this base plate here. So the center point of the view, the boundary, position for the label, and then position of the view. That's very straightforward. Let's reproduce. Let's not reproduce, move that. So I can change the setting for this view as well to make it different. So let's load base blow up 1 in 20. There we go. You can see it changed the specification as well, what we can see. So it's got rid of the hung down bolts, got rid of the grid labels. So again, I can go to dimensioning and I can start to dimension this this base plate. Okay, so we've got that. Let's put some edge distances on there for the ground worker when he makes his template. Let's do that again. Like so. So we can put the information on for the base plate as well. So we can add the part mark. So if I say I want the full name, so let's say I want the profile, but I also want to include the length. You can see there that we've got the profile is this first bit 25 by 450, and then the length is 450 also. So we can reposition that. We can add a box. We can do all kinds of editing with that. But for the purposes of this, I just want to show you how quick that is. We can also use those view tools to do a section view as well. So let's do a section through that base plate. Let's specify the view boundary and let's put that actually below there. So let's reposition this. Let's bring those in, tidy that up a bit. Let's align that up here so I can align the center line with that line. Let's bring the hold down bolts back in. So we'll go to filter, bring those back in. I can change the, whoops, grab that handle. I can change the depth like so, and then I can add further info onto that also, such as the embedment and the projection and the grout allowance. I can add a note to that dimension, so double click the dimension, go to tags. I can label that as grout, like so. Okay, very straightforward. I can also use that tool to create 3D views and roof plans. So let's go to GA drawing. Let's pick 8 meters. Let's say that's a plan view. Let's say that's roof. So we store that. Open the drawing, create. And these views are created directly from the model. So any information, any detail you've got in the model is reflected directly on the drawings. And that's true for changes too. Any changes you make to the model are immediately represented on the drawings. Okay, so you don't need to worry that it removes the need to have to change the model and change the drawings. Everything is brought through by default. So we can change the depth just to include the eaves beam. So we'll let that work. Let's say we want to look a meter down, don't we? Because the eaves beam was set at 7 meters. There we go. So we can see all of the purlins. And then we can start to put part marks onto here. So let's use the part mark for that purlin, part mark for that rafter, and so on. We can actually use this component over here, the drawing content manager. So if I synchronize that and now show that part, I've got my assemblies down here with the marks. It's showing only the ones that I've got marks for. But if I show everything and I want to put all the part marks on for my rafters, for example, if I search rafter, you can see anything with a 0 in the mark quantity doesn't have a mark. So I can select all of those and I can say add mark for all the rafters. I can do the same thing for purlins. So I can say search for purlins. I've spelt that incorrectly. Let's select all the purlins. I haven't selected all of them. Let's start again. Select all those purlins. You can see they're highlighting and I can say add the mark like that. It's a very quick way to handle the part marks on your drawings. Okay. So there's my roof plan. Again, I can create sort of building sections through here. So if I do a typical section through a bay, I can then position that on the view, change the depth to include the full height of the building. I can move that out of the way. I can align that section. Let's just change that to make it fit a bit neater. Get that on. Let's move that over just a touch. Nice and neat, like so. I don't have to create a section each time for every bay either. If I know that they're repeated, I can simply go to my annotations and I can just create a new section mark like so, and it will just repeat that section mark, okay, without the need to have to keep creating sections. And again, I could just tidy those labels up just to make sure they're nice and neat, like so. So editing is very quick, very swift, very straightforward. Okay, it's not too laborious. So what do we do about fabrication drawings? We're going to create it directly from the model using what I like to call the wizard. But the first thing I need to do is create a selection filter that excludes cold rolled elements. So I'm going to tell Tekla to ignore any part that has a profile that begins with metsec or met. So that is the code for all of these metsec items. So if I show you what I mean, let's bring up the specification for that purlin. So the profile for that purlin begins met, which denotes that it's a metsec profile. So if I create a selection filter that excludes that, you'll see that I'm able to select everything that is not a metsec item, like so. Now excluding bolts. Okay, so I want to create fabrication drawings for everything that isn't a metsec part. So I select all the parts that aren't metsec. I start the drawing wizard. I'm going to exclude single parts on the assembly drawings, and I'm just going to create those drawings. So what Tekla is doing now is it's running through that model, it's looking at all of the objects, and it's applying the appropriate layout based on the rules that we set by default. Okay, you don't need to configure this, this is configured for you. And it's actually creating not only the assembly drawings, but it's also creating all of the single part drawings by selection as well. Okay, so it's actually creating all of the manufacturing drawings that you're going to need all at once. So we'll just let that finish. I'm intentionally not shortening these sequences because I think it's important that I do this live so that you can actually see how long it's taking. I don't want to give you the impression that we've doctored the demonstration heavily. This is all in real time. Okay, so that's finished now. So let's have a look at the document manager to see what we've got. So you can see we've got a long list of drawings. Okay, so if we start having a look at the single part drawings first, so I'll use the filters on the left hand side to pick those out, and we'll filter them by mark. So we'll put them in alphanumeric order. So let's have a look at F1. So that's a base plate there. So you can see what we've got. We've got the part, which is dimensioned automatically. We've got a little table here that tells you what mark they are, what profile they are, their grade, how many, what lengths they are, their area, and their weight. And then you've got a little call off list up here, which tells you how many you need in each of the assemblies. Okay, so for columns 1 to 10, each one of those assemblies needs one of these base plates. F6, this is the haunch, the main eaves haunch. So you can see what I meant when I said 2 of 1. So you've got a single cut down the web and you get 2 haunches, and each of these rafters needs one of these haunches. You've actually got 2 for R5 and 2 for R6, which probably means that there are 2 R5 and 2 R6 assemblies, and 2 R7s as well. So you need 10 of these in total. Okay, so you need 5 blanks, makes 10 rafters. That's your rafter end plate. So again, you can see it's all dimensioned, all the holes are specified, conforming to these general notes. So if they're not labeled, they're 22 diameter. You get the idea. I won't bore on with all of these. There's a gusset plate for the bracing, but you get the idea. Then let's have a look at some of the shafts. So that's a bracing. There's one of the stage cleats. What have we got here? We've got SP2, that's for the ease beam. There's your column blank. There's your rafter blank. Okay. Hopefully what you can see is that there's no editing required on any of these. And that's really the main benefit of technical structures, is that it automates all of the production of the manufacturing information from the model. So let's have a look at some of the assembly drawings then. So we've got some bracing. Let's have a look at those. So there's vertical bracing, there's your purlin bracing. Okay, let's have a look at the column. This will give you a better idea of what we're looking at. So we've got a column. So we've got section views are created automatically. I mean, adjust the weld positions and adjust the dimension positions to suit your own preferences, but it's probably not necessarily necessary in all cases. There's a section through the top. We've got a top view and a side-on view. We've also got a bill of materials up here. So this is telling your fabricator which parts he needs to manufacture this column. You've got weld specifications where appropriate. Again, where there are no holes or welds specified, they conform to the general notes here, 22 diameter holes and 6mm fillet welds. You've also got your execution class there and your CE marking box too. But very little editing is required on these fabrication drawings. Let's cycle through a few more. There's another column. Let's have a look at a rafter, R1. So not fitting exactly on the page, but we can adjust that. So if we go into the view, we go to attributes, we change the scale to 1 in 10. Let's see if that fits a bit better. Let's change it to 15. And we've got a fit. Okay, so that's okay. And again, very little editing. You've got all of your running dimensions for your cleats and things taken from the end. You can see what I meant when I was explaining about the handles on the orientation of the parts on the drawings. Once you come to produce them, I drew the start point at the ease end, so I've got the ease haunch at the left-hand end. That does mean that I probably want to zero this dimension, which is very straightforward. I just grab that and reposition that dimension as long as I've got drag and drop on. So again, I can just grab that handle and it will reset that 0, so all the running dimensions are correct. Okay, nice and straightforward. And that's pretty much the fabrication drawings. Hopefully you can see that there's not too much work involved in those. It's very automated. The simpler the assembly, the simpler the drawing, and the less editing you're going to need. So things like beams, floor beams, mezzanine beams, straightforward columns, they will require absolutely no editing whatsoever. NC file production. So while I've got the filter on for the steel, I'll go to my export. I'll go to NC files. I will tick both of these options here so we create NC files for both plates and profiles. So I will select all of my hot rolled steel and I will hit create. That has finished already. So if I open my model folder, you can see I've got these two files, plates and profiles. So I've got all my NC files for plates and all my NC files for profiles. So all I've got to do is package all of these NC files up, send them to either my machines or my supplier if I like to order kit parts, and they can start processing that steel straight away. That's all I need to do for the hot rolled steel. If I then reverse this filter and say select only the METSEC elements, so my cold roll library, if I then go to the METSEC tool, I've got what we call the file transfer. So I double click that. I give the project a name. So let's just say it's job number 10,001. Apply, create. That's going to finish. And what I've got in there is I've created 4 files. I've got the CAM data for the machine, and then I've got my logs. All I've got to do is send that to METSEC, tell them where I want it delivered and when I want it delivered. And again, they can start manufacturing on the basis of that information. I don't need to create drawings for anything that anything that conforms to METSEC's literature. Within the library, within the model folder, you get a required drawings.dat file. So you can see there that I need to create drawings for CR2 and CR4, which are going to be my eaves cleats, my eaves brackets, and that's because there's a peculiar angle on the end probably. So I can just spend a second or two to create those in the same way that I did my assembly drawings and send those to Metsec. Again, very straightforward. There's various exports as well, so you can export IFC files if you're familiar with BIM protocols, if that's something you're being asked to produce. So if I produce that as a coordination view 2, location there, and include all objects, I can export that now. We'll let that run. That's going to create me an IFC, which I can now view using Trimble Connect.